Okay, so thank you very much, Marichel, for your introduction. I will give you my speech in English because all the presentations in this panel will be in English as well. So, and before we get started, I want to mention that I'm glad for being here this morning with all of you. I'm grateful to Sidaya and Yurikat and the program committee members for allowing me to attend to this 8th edition of the Artificial Intelligence and Big Data Congress, not only in this streaming session as a moderator, but also physically yesterday at the Auditory Axe in Barcelona, where I got the chance, as many other attendees, to witness the cutting-edge solutions and applications of the artificial intelligence. I want to thank them for helping us to make visible all the artificial intelligence members of the community in the Digital Catalonia Alliance and the other players that we have in the Catalonia Artificial Intelligence Strategy, such as the Artificial Intelligence Research and the Observatory of Ethics and Artificial Intelligence as well. And last but not least, I want to thank all the sponsors and collaborators as well for making this Congress possible. And it's time to move on to this panel. In this session, we're going to have two speakers presenting their experiences and solutions based on synthetic data and transformers. And as you may already know, in the field of application, for many reasons, there is a need to generate synthetic data and to train artificial intelligence models. And for those unfamiliar with this term, synthetic data is any kind of information that has been manufactured artificially based on real data sets, and whose purpose is basically to mimic data that can be used to train machine learning algorithms or to test mathematical models. So the aim of this session will be showing how different emerging technologies allow this synthesis of data, and such as the so-called transformers. The examples presented will help us to better understand what types of synthetic data exist, how they are generated, and what their characteristics are, and what needs have to be considered when using them to train models. So to do so, in a few moments, we are going to have to give the floor to our two speakers invited in this session, Daniel Didac-Fortuny and Daniel Burton. I want to thank you too for joining this session. And they will be presenting their use cases of synthetic data and their applications. So the first speaker of the session will be Didac-Fortuny, a data scientist from Adevintia, Spain. He's a PhD in physics and data scientist, and in the last year has been developing solutions based on machine learning in different companies in Barcelona. He has also driven several initiatives to take advantage of data and projects with social background, and his presentation will be covering the recent projects involved about curriculum vitae parsing with BERT in InfoJobs. And our second speaker will be Daniel Burton, a head of creative in Synthesia, a company based in UK. He is a creative technologist with a track record delivering technology innovation for creative industries, and his most interesting current challenge is to figure out how machines can augment human creativity. And he has also been experimenting with creative models. And so the title of his presentation will be Synthetic Data, a New Paradigm Shift in the Content Creation. So thanks again for you two for being here this morning. And I'm going to just give straight the floor to Didac. You can get started with the presentation at any time.
Thank you, Cristina. My name is Didac-Fortuny. I am data scientist in Adevinta, Spain, in InfoJobs. That is part of Adevinta, Spain, and I will be explaining a project that consists of extracting structured information from resumes or curriculums uploaded in InfoJobs. That is the main job portal in Spain. But before that, a couple of words about Adevinta. Yes, the purpose of Adevinta, the mission is to create perfect matches. That means helping people to find what they are looking for, leaving a good footprint in the world. And to do so, what we do is to operate different web portals, marketplaces in a lot of countries around the world. Okay, in my talk, first I will explain why we decided to do this project. Then I will cover why transformers and synthetic data have been crucial to develop this particular project. And finally, I will give you a few words about the impact of this project since it was implemented. In InfoJobs, when we decide which projects to attack, we have a look at the feedback that our users give us to see which are the more relevant topics to cover. In this case, we focused on two regular feedbacks. The first one is that people in InfoJobs wanted to upload their resume in PDF in our platform. We were not allowing them to do this because we thought that if they upload an unstructured PDF in InfoJobs, they would stop filling the InfoJobs profile, the structured data in the InfoJobs profile, and we use all this structured data to give them better recommendations, personalize their experience, etc. So we didn't want to lose this structured data. And the second feedback was that the process of updating precisely this InfoJobs profile was quite long and complex. So we thought, okay, why don't we first let the users upload their CV in PDF and then build a machine learning model that automatically understands what's inside the PDF, the curriculum in PDF, and fills all the fields in the InfoJobs profile in an automatic and fast way. In other words, this is solving a named entity recognition task that consists of assigning to each word or part of fragment of a given text, in this case, an extract of a curriculum of a person, to assign a label. For example, this is a date, this is a location, this is the organization, or the email, the name, the phone, etc. All the fields that can be present in a normal curriculum. And to do this, we realized that we needed sophisticated machine learning algorithms like transformers. And before continuing, let me clarify a couple of questions. When I talk about transformers, I am talking about a particular kind of implementation of neural networks, a particular architecture that incorporates attention mechanisms. This means that when processing a sequential data, a sequence of data, for example, a sentence that is a sequence of words, when processing each word, instead of processing each word separately, when we are processing one word, we take into account the words before and the words after that to process each one of the words. This is what we call, in plain terms, attention mechanisms. And then when I talk about BERT, I am talking about a specific implementation of this transformer architecture in form of a language model developed by Google that what it does is predicts a gap in a sentence. For example, if you have a sentence and you remove a word, BERT is able to predict which is the missing word. Okay, with these concepts clarified, what we did in InfoJobs was taking this BERT model, this transformer, and modifying it a little bit. Instead of predicting a missing word, this is not what we are looking for. We changed the last part of the neural network, and we introduced there some classifier layers in such a way that for each word in the input text, for example, April or 2016, we can predict which is the more probable class. In this case, would be 2 dates. This is what we call CBERT, this model, this CV parsing model based on transformers, based on BERT. And here we thought, okay, are we happy with this? We can solve the CV parsing problem with this solution. And we realized that this was not enough because in some cases, for example, this example here is an extract of a real curriculum. We have 2 different user experiences. The person has worked in Grupo Calixo and in Extin SA, but the model is detecting in the middle a couple of dates and a location. When we trespass this information into the InfoJobs profile, we need to assign these dates either to the first experience or to the second experience. So we need something more complex than a single prediction. And that's why we needed to reinvent the model and modify it to perform 2 predictions per word instead of just 1. To predict, for example, that April, it's a date, but also it's starting a new experience within the whole curriculum. Okay, we thought, okay, we are ready for putting this into production. And then we faced another problem. BERT is only trained for text up to 512 tokens because as for processing each word, you need to process the entire sentence. For very long sentences, the complexity of calculations it grows exponentially. So this is why there is a limitation. To solve this, we developed some sort of splitting the document in different chunks of 256 tokens, and then doing some overlapping predictions and averaging the results. I will not go in detail here because it's not the topic of the talk, but the main idea here is that we needed to, again, play with this already existing transformer to solve the problem that we had in the beginning. And to implement all of this, this is our main stack, BERT. I already talked to you about this. Is the language model developed by Google. Hugging Face is the Python library that we use to implement BERT, and PyTorch is the deep learning framework that we use to make all the calculations of mathematical tensors that are behind all these ideas that I just explained. Okay, let me pause here for a moment and recap the 3 main points that I have covered about transformers. First, when you have complex NLP tasks, you need sophisticated deep learning architectures like transformers. If you have a simple task, do not use transformers, do not use deep learning. It will only add complexity to your problem. But for some problems, you cannot avoid it. Second, transformers are powerful for solving NLP tasks, but you have to know how to adapt them and use them wisely to solve your problem. And third, you don't have to reinvent the wheel. There are existing libraries and a lot of code already done. So it's not as hard as it would seem to implement a model like this. Okay, but for any machine learning, machine learning model, you need to have labeled data. In our case, for training this model, we needed some curriculums in which we already know which are the different parts to train the model and let the model understand the patterns that a curriculum has. Where can we find this training data? And this is where we realized that we could use synthetic data. Because in InfoJobs, we have data from our users for more than 20 years. So we thought, why don't we use all this information that we already have, that it's labeled because it's in our own structured tables, and we create synthetic CVs, millions of synthetic CVs. This is what we call Frankenstein CVs, because at the end we are creating new people based on parts of already existing people. We would be able to create millions of these Frankenstein CVs and train the model that I presented at the beginning. This is the first version of CBERT. Okay, we evaluated this model using a test set of synthetic CVs, and the model was performing very well. But as you may suspect, when we created a new test set labeling manually real CVs, and we evaluated again the model, the metrics dropped. Not a lot, the model was still good, doing quite well, but not as good as when evaluated with synthetic CVs. We already suspected that this would happen because here what is happening is that the model is not generalizing well. It's understanding the layouts and the structure of the synthetic CVs, but it's not generalizing to an open world. And then what we did is to introduce some humans in the loop. We took a lot of real CVs. We processed them using the first version of CBERT, and these humans were fixing the mistakes that the model did. With this, we ended up having some thousands of real labeled CVs. We could be able to fine-tune the first version of the model and end up having a definitive model that was performing well, even in a test set based on real labeled unseen CVs. And that now I will pause again. The main points of the synthetic data is that first, when you have supervised machine learning models, you cannot avoid having annotated data. But if it's the case, you can do some data augmentation techniques to create your own synthetic data set that can be large enough to train a deep learning model. But you have to be aware that in some cases, like in our case, you need human supervision, some sort of human supervision if you want to boost the performance of your model. And finally, let me explain the impact of this project since it was implemented. Now the users of InfoJobs can upload their curriculum, and when they do this, we compare the extracted information with the information that we already have from them in their profile, and we can suggest some improvements. If we detect something that it's not in their profile, we can suggest them to add it. With this, 4 out of 10 users that upload their CV, we can suggest them something, and 90% of the suggestions are considered useful. And with this, for the reason, the users that upload their CV have a more complete profile, and then they have a better experience. They find a job more easily because we can recommend them better offers and we can give them a more personalized experience. And finally, my last slide, the take-home messages of the whole presentation. First, take time to design the correct approach for your problem. Sometimes you can use an out-of-the-box solution. Sometimes you cannot, but you can use out-of-the-box tools, combine them in a smart way to have a custom solution for your problem. Second, you can use transformers used wisely to solve some NLP tasks. It's a very powerful tool. And finally, don't be afraid to create your own synthetic data set, but be aware of the limitations of your procedure. This project was developed by this team, this multidisciplinary team, one engineering manager, one product owner, a backend engineer, 2 machine learning engineers, and 3 data scientists. Thanks to this combined work, we could succeed in this project. And that's all. You have here my contact information if you want to discuss anything, or we can have questions after the next talk. Thank you.
Okay, thank you very much, Didac. You have already one question. We will cover it afterwards, and we're going to give the floor to Daniel for his presentation.
I wanted to flag this will not be a technical presentation, and that is on purpose because we, as you know, as technologists, we can get very easily distracted by the new shiny toys, by the technologies. We get very excited for it, and for obvious reasons. But I wanted to approach today's presentation from another perspective, which is the user's perspective. If you don't build something that has a real world problem and that you're solving for, then your new technology will just be looking for that problem forever and not solving it. And so I wanted to talk today about synthetic data today from that perspective and what we're doing at Synthesia, which relates specifically to synthetic media and to synthetic video. And we do believe that synthetic media is actually today driving a paradigm shift in how we create content. And we're at the beginning at a very big transformation of how we create content today. So what we see today is that consumers actually want video content, right? There is this statistic that 82% of internet traffic in 2020 was video. This is from Cisco. And I don't have to introduce you to TikTok, YouTube, and all of the other video platforms that actually show us how much interest there is in video content. But at the same time, people have the challenge of actually creating video content is not that easy, right? You have to go from idea all the way through writing the script, getting a camera, getting into a studio, getting an actor, performing yourself, which is never easy. And then you go through post-production before you actually get to a final video. Now, this process, if you've ever created a video, can take weeks, right? And so what we're trying to do at Synthesia is simplify that process and taking it from something that takes weeks to something that takes a couple of minutes. And we use synthetic data to do that. And the way that we see this today is that content creation and specifically video production has gone through a couple of major changes, right? First, obviously, the analog film was discovered, And people started to experiment with it. First, you had silent films, and then obviously with the growth of Hollywood, it really exploded and became a massive economy. Then we saw the next big shift, which was obviously digital sensors, and all of the sensors actually becoming digital, from video cameras first to obviously the iPhone today, that actually works very well as a DSLR camera. But what we're seeing today is that we're at the precipice of another big shift where all content can be generated using AI models. And that is what synthetic media actually stands for. And so at Synthesia, we're actually on the mission to making video creation easy for everyone, right? So many today don't know how to use a camera, don't know how to use a microphone, or frankly, they're just timid to be in front of the sensor. And so many people cannot today enter the creative economy. We're trying to change it at Synthesia with the use of synthetic video. And so we built a platform that runs in Chrome in your browser, where all you have to do as a user is you type your script, you select an AI avatar, and then you hit generate video. We generate a video for you in 2 minutes. So you can go from idea to the video in a couple of minutes. And again, typing out text is something that anyone can do. We built all of our AI systems internally, mostly on again, architecture, and all of the AI avatars that, for example, you see in this mockup are actual real humans that we train our models on when we create someone's AI avatar. Now, very important part of this, apart from obviously building best-in-class AI models, is actually building the SaaS platform itself, right? Again, from the user's perspective, they don't really care what architecture you use. What they care for is how easy it is to actually create video. And what we see today in the enterprise is that the overwhelming majority of documents today are actually written, right? People can write a Word document. People can create a PowerPoint presentation. And the reason for that is simply because typing text is easy. So our whole experience is based on all you have to do is actually type out text, because anyone in the enterprise can do that. But at the same time, as we saw, consumers actually want video today. It's just very hard to create. And so they take that want with them into the enterprise. And so video is actually a way more effective way of communicating in the enterprise. Now, I wanted to also give you a couple of examples of this. This is my own custom AI avatar. It took about 3 minutes of footage of me in a green screen studio to create it. We serve over 14,000 clients at Synthesia, ranging from big multinationals like EY or Teleperformance, all the way to small SMBs. And many of our clients actually have their own custom avatars that you can have. And so what synthetic video in this case allows you to do is actually to scale infinitely. All of a sudden, video gets the properties of software development, right? All of a sudden, you can generate as much video as you need, and you can create in any language that you actually want. So I brought you 2 examples here today in different languages. So let's just look at the video.
Buenas tardes, señoras y señores. Soy el avatar de inteligencia artificial del presentador, Daniel. Fue completamente generado usando IA. Con mi ayuda, Daniel puede crear vídeos en minutos sin la necesidad de cámaras o micrófonos.
And so that's an example, a very simple example of what you can do now using synthetic video. Now, I would never actually dare, I grew up in Barcelona actually, and I would never actually dare to come to a Eurecat event without actually bringing a Catalan version of the same video as well. So let me also show you how I sound speaking Catalan.
Bona tarda, senyores i senyors. Soc l'avatar d'intel·ligència artificial del presentador Daniel. Va ser completament generat amb IA. Amb la meva ajuda, Daniel pot crear vídeos en minuts sense la necessitat de càmeres o micròfons.
Now, That's obviously just a fun example of this, but we're seeing tens of thousands of customers actually benefiting today of synthetic video, right? And so I brought you today an example of one of the big corporations that we work with. And we spoke to them about the differences between working with traditional video and AI video, synthetic data, right? When we started to have the conversation, it came out very quickly, the crazy cost and time savings that synthetic data can actually drive. They saved 70% compared to working with traditional video methods when it comes to budgets. They increased engagement by 30%. And again, this shows that people actually want to watch a 2-minute video. You don't want to send them a boring PDF. They will never read it. And, we've all seen those compliance trainings in the form of a PDF. If instead of that, you can actually provide a 1-2-minute video to explain the topic, the engagement will go up quite substantially. And so this is just one of many cases where we work with clients to help them with their video needs. We actually see text as our competition, right? It's not traditional video that we're replacing. We love cinema. We love Hollywood. This is more for video to exist where previously only text was able to be generated. And so if we talk a bit about the future and where this could be going, we do believe that in 10 years' time, anyone on their laptop will be able to create a Hollywood-grade movie with nothing else but their browser and a lot of creativity, obviously. If you think about it, this might sound, a bit futuristic today, but if you think, for example, what the synthesizer did for music production, AI models will do the same for video. Synthesizers obviously did not replace the instruments. People still learn how to play instruments, but at the same time, the synthesizer allowed anyone to recreate any type of sound that they wanted to do. So all of a sudden, the barriers of entry were much lower. Today, anyone who actually learns through a couple of YouTube videos how to play on the synthesizer can create a top leading hit, which has not been able before. Imagine if that actually applies to video as well. What kind of creativity that can unleash? If we think, this is analogous to the economic growth that the internet drove. In 2016 alone, the UX economy, the internet actually was attributed more than 20% of the GDP of the US economy. If we think about it in economic growth terms, synthetic data really has the opportunity to transform content creation. Thank you so much, and we'll be looking forward to your questions.
Well, thank you very much once again, you two, for your impressive presentations. Let's give some minutes for, let's give the attendees to send their questions. But we have received some already for Didac. The first one is from Joan Luis Astray. The question is the following one: developing your business model on Google technology implies a cost in license per month or per year for a company. Could you have developed it in open source technology? If yes, it has a higher cost?
Thank you, Cristina, and thank you to the person who asked the question. It's a very good question and relevant, because as we are processing a lot of curriculums in this case, we couldn't afford a model in which we had to pay for each prediction. In this case, even BERT is a language model developed by Google. It's open source. It has been published in a lot of scientific papers, the structure or the architecture of the model. And apart from that, have been implemented in code by the people on Hugging Face, this Python library that we are using. So for us, it doesn't have a cost for doing this. The only cost is that we have to train the model and serve the model in our own instances. And for this, we need powerful instances to do all these predictions, because it's a deep learning complex model. But as it is open source, we don't have to pay for using the API of Google or anything.
Perfect. I think that answers the question. So the next question as well goes for you, Didac. Carmen Tarjak was the person that asked this question. So does this technology not greatly depersonalize the selection process? Maybe it biases the data by generating this synthetic data in a way. And beside that, from this time saving or what advantages has offered in this project without having artificial intelligence?
Okay, thanks. And thanks, Carmen. Again, it's a very relevant question because we don't want to lose the human part of our application, no? And for the reason, we have a team of UX researchers that are constantly interviewing with the users of InfoJobs and telling us what they think to precisely don't lose this human point. In this case, the project of extracting this information from the curriculums was solving a particular pain of some users, because users spend a lot of time doing their own CV in Word or whichever tool they are using. And then when they entered InfoJobs, we asked them, okay, you have to write everything again. So they were not happy about this. So the project was to solve this problem. But apart from this, one of the other implications of this project is that now that they can upload their PDF, they can upload like creative PDFs, or they can structure the information the way they want. They don't have to keep the structure or the fixed structure of the InfoJobs profile. So they can create more personalized curriculums, upload them in PDF, and the companies that will interview them will see them. So this, in this case, is adding more personalization to the process than what we had before, that it was just fill all the fields and forget about everything else. And finally, and in other aspects of InfoJobs where we also have artificial intelligence algorithms, it could seem that we are personalizing, losing this personalization, but at the end, what we try is that our users find the offers that they are looking for as fast as they can. They are asking us for this, so we need to use all what we can do, even artificial intelligence, to serve this purpose. And finally, I have 1 more minute. About the biases of age and gender, precisely again with these Frankenstein curriculums that I presented, these fake curriculums, because they don't have a particular gender or age, because they are based on the combination of different people of different nationalities, ages, and genders, is one way of at least solving a bit the problem of possible biases.
Okay, thank you very much, Didac, once again. And let's move to Daniel. And we have received a question from you that says, have you developed any particular intellectual property model that allow you to show at international level mechanized images of real people as your video? If yes, what kind of intellectual property clauses have people imaged by your system to sign to protect their image or allow you to show it? If you have this information, of course.
Very important question, and thank you so much for asking it, because I would actually go beyond the legal framework that we use, and I would want to also speak to the ethical frame that we do, because we actually protect people's likeness way beyond our legal requirements. So first of all, the most important thing to mention is that we actually wanted to build ethics into the company from the start, and we take that very seriously when it comes to product decisions and business decisions. One of these core principles is that we do not create someone's likeness without their explicit consent. So this obviously also tells you about the legal frame. So we actually go beyond the question of, what are the intellectual property restrictions around using that image, because we would never create someone's likeness without their explicit consent. We have a KYC-like process where people actually submit footage to us for us to train their AI avatar. We're obviously very happy to do that, but a human always checks the consent of the submission there to make sure that it's actually a real person who's asking us to create a custom avatar on their own likeness, right? So in this matter, this actually goes beyond the range of the question that we have here around intellectual property. It's also very important to note that only that specific person will have then access to that custom avatar. Now, when it comes to the stock AI avatars that we have on the platform, those are based on real humans, real actors who get compensated for us using their likeness. It's also very, very important to note that we protect their likeness, right? AI avatars don't have feelings, they don't have personalities, but we do protect the humans behind the AI avatar. So for example, you can't create content around politics, around religion, or restricted services and products like guns or tobacco with a stock avatar. You can obviously express your own political and religious views with your own custom avatar, but not with the human actors.
Perfect. So we have another question for you, Daniel, from Joan Mas from Eurecat. And the question says, can you give a short insight on the technological basis of Synthesia's work?
Absolutely. So it will be limited what I can say about it. All of our technology is actually proprietary. Two of our co-founders are leading computer vision professors. So Professor Nisner, he used to be at Stanford. Now he leads one of the institutes at the university, a technological university in Munich. Professor Agapito Lourdes, she is a professor in computer vision at UCL here in London. And 30% of our employees are actually PhDs. So we build all of the technology internally. What I can say about it, our core infrastructure is actually built on GANs, but obviously all the time we experiment with other models. I think with this audience, I don't have to mention how fast and quickly this space is actually moving, with new models coming out every single day, papers being pushed out basically daily as well on the new technological advancements. We are built mostly on GANs, but do work a lot with the new models coming out.
Great. So we have almost 7 minutes left. So another question for you, Daniel, from Hugo Van Merth. Does the artificial intelligence video tool have a playground or free version to access for testing?
Absolutely. So if you go to synthesia.io, we'll share it for sure. You can generate the free demo right there. We thousands and thousands of videos are generated every single day. Actually, we're just about to come out with our Christmas campaign as well. So apart from the free demos available today on the website, you will also have the ability to send a personalized video with Santa wishing Christmas to your loved ones, for example.
That's great. We have to try this function. Another question for you, and from Marco Orellana, that says, a few months ago, we saw how Bruce Willis sold his image to artificial intelligence company. What do you think about this vision of future where some actual actors could preserve their image in the screen forever?
Oh boy, so let me actually separate that question into two. So let me talk first to the Bruce Willis question, because actually there was some misreporting on that side, but then let me talk about the larger question about celebrities using their likeness. So on the Bruce Willis side, actually, first it was reported that Bruce Willis sold his likeness for creation of an AI avatar. Then a correction came out about a week after saying that he did partner with a specific company for a specific campaign for his likeness to be used, but he never actually allowed anyone to use his likeness beyond that. There are very big questions here about consent. Obviously this depends on the ethical stance of the company that you work with. But for example, at Synthesia, we would never actually do something like that where Bruce Willis has not explicitly consented for the use of his likeness beyond that one campaign. So to give you an example, we worked before with David Beckham to help him speak in 8 different languages to combat malaria. Obviously, we had explicit consent. We had a campaign with Leeds and Leo Messi, where you could send personalized videos with Messi, inviting them to the next game. Again, Leo Messi obviously consenting to that. So Bruce Willis's case, I find that problematic because we would never do that without consent. On the other hand, I deeply believe that synthetic data will give a crazy advantage to celebrities. Imagine that all of a sudden, let's take, I don't know, Paris Hilton, for example, right? Paris Hilton is famous for charging ridiculous amounts of money to going to a club, sitting down, sipping some champagne, and obviously getting people through the door with her being there. Now, imagine that situation where she could actually scale herself infinitely. So if Paris Hilton, for example, had her AI avatar, she could be sending personalized videos to every single person who signed up for a party before they even get into the club. She could send, personalized messages afterwards. And all of a sudden, in one night, Paris Hilton would not be only making money for just one club, but obviously for all of the other ones. Now, this is a very let's say, light pop culture example of it, but you can think about this for every single celebrity as well. Synthetic video and synthetic data in general will be a massive value driver for celebrities.
Well, thanks once again for answering this question. And we have only 3 minutes left, and I would like to ask you 2 very short questions from my side. So, what happens when a curriculum vitae that you receive has been generated in PDF, but with a picture? Does your software work in that way, or your model?
Thank you. Yes, again, a relevant question. This happens. We counted how many times this happens, and it happens, but it's a very low amount of time. For the moment when this happens, the curriculum is not processed. We have some ideas about adding like a layer of OCR in the middle, extracting the text. It is not quite difficult to implement, but again, since we are we decide what to do in base of how the users are giving us feedback. For the moment, this is not a very big pain, so we have not focused on this. We know how to solve it, but we have been doing other things instead of this.
Great. So my final question goes for Daniel, and it's related to the uncanny valley. So when you have this strange feeling when you see this robot behaving like human, but it's not 100% accurate, how are you dealing with this thing?
Absolutely. It's such an important question, right? And the most important thing to flag here is AI video and synthetic video is very nascent, right? We're just at the precipice of this massive paradigm shift that we're talking about. Today, the AI avatars are great for conveying information, right? But as you say, it's very easy to actually see when kind of the model doesn't work the right way, right? It's obviously very hard to mimic real humans. There's so many separate bits about communication, right? So me here talking right now, I'm using my hands, I'm moving slightly, I'm gesturing, my face is obviously moving. So there's so many different variables that go into human connection that recreating all of those will take time. I do believe that we will get there, and we can already see, we're about to come out with the next generation of our AI avatars. And those avatars there, we can already control some of the emotional responses. So the AI avatar will be able to raise its eyebrows when it's talking about something interesting. It will be able to give you a nod. These are kind of the first steps that we're taking towards that future that you're talking for. But I am quite certain that for the next 3-5 years, we will definitely have that feeling that something is tickling your lizard brain, your old brain, saying this is not a human, and hence, the brain obviously goes into defense mode in that case.
Well, so perfect. Thank you very much for your presentations, your time, for being here. And that's it for this panel. We don't have any extra room for further questions. So thanks once again. And we are going to move on with the 10-minute break. And at 1:30, we'll start the next session called Artificial Intelligent Decision Support System. And it will be moderated by Cristina from IDEA UPC. So that's it from our side. It was great to work with you guys, and I hope to see you soon. And for you, Daniel, I hope to see you physically at a given point in the near time.
Thank you.
So thank you so much.
Thank you so much.